Far beyond the reach of human hands, across billions of light years of space-time, the universe breathes secrets into existence. Most are silent to us, lost in the cosmic roar. But sometimes a whisper breaks through a pulse of energy so profound, so utterly alien, that it forces us to reevaluate everything we thought we knew about the cosmos and our place within it. For decades, astronomers have cataloged the static, the hum, the predictable rhythm of celestial bodies. Then, in 2007, an anomaly burst onto the scene, the Fast Radio Burst, or FRB. Detected by astronomer Duncan Lorimer and his team, the Lorimer Burst, FRB 010724, was a mere 5-millisecond flash, packed with more energy than the sun emits in a day. These enigmatic bursts became one of astronomy's greatest mysteries. They appeared to originate from distant galaxies, billions of light years away, yet their exact sources remained elusive. Most FRBs are one-off events, believed to be the catastrophic birth cries of black holes or the violent death throes of super-dense neutron stars, never to be seen again. Enter the Canadian Hydrogen Intensity Mapping Experiment, or CHIME. This groundbreaking radio telescope in British Columbia, with its unique half-pipe design, was engineered to map the universe's expansion, but quickly became a prolific FRB hunter. Its wide field of view and incredible sensitivity made it a super detector for these fleeting cosmic signals. On a cool spring evening in April 2019, deep within CHIME's vast data streams, an algorithm flagged something extraordinary. It was FRB 190425, a pulse of radio waves arriving from a region of space approximately 3 billion light-years distant. A powerful, isolated burst, seemingly indistinguishable from hundreds of other CHIME had already detected. The initial analysis confirmed its high dispersion measure, a telltale sign of its journey through vast expanses of cosmic plasma. This characteristic allowed scientists to estimate its incredible distance. It appeared to be another typical, powerful, non-repeating FRB, a transient cosmic event that had flared once and then vanished forever into the background noise. Astronomers cataloged it, added it to the growing list of cosmic curiosities, and moved on. The sheer volume of data CHIME produced meant that while each new FRB was exciting, they were becoming less of an anomaly and more of a regular occurrence. The expectation was clear. This signal was a singular, cataclysmic event, its energy expended in a single, brilliant flash. For months, the sky in that specific direction remained silent. Other FRBs from different sources were discovered, some even repeating with unpredictable regularity, like the famous FRB 121102. But the source of FRB 190425 offered nothing more. No faint echoes, no subtle lingering hum, just a cosmic void it had emerged from. The scientific consensus strengthened. FRB 190425 was a typical one-off event, perhaps the merger of two neutron stars, a cataclysmic explosion that ejects incredible amounts of energy but leaves no lingering trace. Such events are violent, brief, and irreversible. The universe, after all, is a realm of ultimate events. As the year drew to a close, the CHIME team embarked on a meticulous reanalysis of their immense data archives. They were hunting for patterns, subtle connections, or perhaps even missed signals. It was a painstaking, often monotonous task, sifting through petabytes of recorded sky. Then, something impossibly familiar appeared. Buried deep within the data from May 2019, just weeks after the initial detection, a faint, undeniable signature materialized. It was located in the exact celestial coordinates of FRB 190425A. At first, it was dismissed as an instrumental glitch or perhaps a terrestrial interference, a phantom echo of a previous event. But as the team applied their rigorous filtering protocols, the signal remained. It was a second, distinct burst of radio waves. Not a continuous emission, not a stuttering series of pulses, but a single, isolated echo. An echo that had arrived from a source billions of light years away, and then, just as suddenly, had fallen silent once more. The implications of this second detection were staggering. FRB 190425, it was no longer a one-off. It had repeated, but this wasn't like the many repeaters Chime had already discovered, which fire off multiple bursts over weeks, months, or even years. This was a singular, isolated echo, a solitary twin separated by just over a month. The data underwent intense scrutiny. Every parameter of the second signal, from its dispersion measure, its smear through cosmic plasma, to its duration and frequency spectrum, was meticulously compared to the first. What they found was astonishing, an almost perfect match. The cosmic fingerprint was identical. It was the same source, speaking again. This wasn't simply another FRB. It was a phenomenon unique among the thousands detected. An FRB that had repeated exactly once, then seemingly ceased. This defied the two established categories of fast radio bursts: the single, catastrophic events and the persistent, irregular or periodic repeaters. It was an entirely new class of cosmic communication. The source, a compact galaxy roughly 3 billion light-years away, was re-examined with renewed urgency by powerful optical telescopes like the Hubble Space Telescope. Was there any unusual activity? A visible anomaly? The galaxy appeared normal, a swirling collection of stars, gas, and dust, offering no immediate clues to the powerful bursts emanating from its depths. The discovery of FRB 121102 in 2014, the first confirmed repeating FRB, had already revolutionized the field. Its multiple, unpredictable bursts pointed to persistent, perhaps highly energetic, neutron stars. But FRB 190425A's binary echo didn't fit this model. It suggested an event or object capable of a precise, delayed, second identical emission. The scientific community buzzed with theories. Could it be a rare binary system, where two highly energetic objects, perhaps neutron stars or black holes, orbit each other in such a way that their interaction produces precisely two identical bursts separated by a specific period? The timing and perfect repetition were the key puzzles. Another hypothesis considered extreme stellar flares or starquakes on a magnetar, a supermagnetic neutron star. While magnetars are known to produce FRBs, a single, perfectly identical follow-up burst weeks later stretched the limits of known magnetar behavior. Such an event would require an extraordinary, almost impossible, cosmic coincidence. The possibility of gravitational lensing was also explored. Could a massive object between us and the FRB source have bent the radio waves, creating two distinct paths of slightly different lengths, causing the same burst to arrive twice? This would explain the identical nature, but the precise timing difference of weeks, was difficult to reconcile with typical lensing scenarios. With the incredible implications of a unique repeating signal, astronomers globally swung into action. Radio telescopes from Arecibo to Parkes, from the Very Large Array to FAST, were pointed towards the specific coordinates of FRB 190425A. The hunt for a third burst or any further activity became a top priority. Weeks turned into months of intense, round-the-clock monitoring. Sophisticated algorithms scanned every nanosecond of incoming data. The hope was that the universe would speak a third time, offering more clues, more data points to unravel this profound mystery. But the silence that followed the second burst was absolute. The source of FRB 190425, a galaxy billions of light years away, remained stubbornly quiet. The twin bursts, once a beacon of excitement and discovery, now settled into a perplexing cosmic silence. It was as if the universe had sent a message, waited for us to acknowledge, and then deliberately ceased transmission. The silence wasn't just a lack of data. It was a new data point in itself. It painted a picture of an event so precise, so incredibly rare, that its two emissions stand alone as an unprecedented astronomical anomaly. The mystery deepened, transforming from what caused the burst to what caused exactly two identical bursts. The scientific community found itself in a unique predicament. How do you interpret a signal that defies all known categories? FRB 190425A's binary echo challenged fundamental assumptions about transient astronomical events. Its singular repetition forced a rethinking of the very mechanisms that power these colossal, distant flashes.